Now that you have some experience with deploying using Spinnaker on Amazon, on AWS, using AMIs, now I'm going to cover containers in the next section. And when I'm talking about containers, I'm talking about Docker. So we'll be using Docker to package our software and then deploy it on a cluster like Kubernetes. First, I will explain you what containers are. So if you already know what containers are, you can actually skip this lecture and go straight to the Kubernetes one. Let's start with virtual machines versus containers. Here on the left, you see a virtual machine like an AMI on AWS depicted. An AMI stands for Amazon Machine Images, which is going to run on Amazon. That is the image that you need to run on OS, to run your Ubuntu on AWS. So if we start at the bottom, Amazon supplies you a server and installs a host OS on that. On that host operating system, it installs Zen, the hypervisor. And the hypervisor is going to manage the virtual machines. You don't have access to that. That's what Amazon manages. You then spin up an AMI. That's an EC2 instance that starts from an AMI, an image, that contains then a guest operating system, the binaries, the libraries, and your application. So the guest operating system can be an Ubuntu or a Windows machine, and that then contains the binaries, the libraries that are necessary to run the OS and your application. What we did in previous lectures is to package our application in a Debian package, then bake an AMI, so bundle the guest operating system with the binaries, the libraries, and then the application in a Debian package format, save that as an AMI, and then Spinnaker can launch that for us one or more EC2 instances based on that AMI. So here in this example, we have 3 AMIs running on a hypervisor. This is actually a pretty good solution, but it has some downsides. And that's where containerization comes into the picture. So here on the right, we then have a container depicted. You can run, and this is not on Amazon, but you can run a container on a server on a host operating system and still have isolation. Because the isolation happens in the kernel, in the Linux kernel, which is in the operating system itself, and you can then run containers on the host operating system. So here we have 3 containers. In a container, you bundle your binaries, your libraries, and application, but you don't need the guest operating system anymore. So one of the main differences is that when you spin up a container, then it's instant. It's less than a second, where the guest operating system needs to, like when you boot an image, an EC2 instance, it takes 1 or 2 minutes because the whole guest operating system needs to run. So here we have 3 containers, and you don't need the guest operating system, so the container will also be a lot smaller. And then here you see on the right that you have the Docker engine. So the Docker engine will make sure that the container starts. This example could be a Kubernetes cluster, for example, that you run on-prem on your own hardware. You just have the server, you install the host operating system, you install Kubernetes on it. It will also install the Docker engine, and then you will have containers on it. On Amazon, you still have the hypervisor that then runs the guest OS, the OS that you run, that you are responsible for, and then you can run containers on that. It depends really whether you're going to be able to run bare metal, maybe on-premise in your enterprise, or you're going to use Amazon, a cloud provider that only supports virtualization first. It gives you some overhead, but with the latest instance families on Amazon, the difference between virtualization and bare metal is very, very minimal. In some cases, Amazon also can supply you with very minimal optimized base images that only contain Docker engine, and then you run all your applications in a container. All the libraries, the specific libraries that you need for applications run in a container. So this operating system, this guest operating system on Amazon, or if you run on-prem, this host operating system is actually a very, very minimal system. It only has to contain the Docker engine, so it can be very small. So this is then an example of running containers on a cloud provider where you still manage your virtual machine, a minimal machine that just has Docker engine and then runs your app A, B, and C within the containers. If you run Kubernetes, the guest operating system contains Kubernetes and the Docker engine, and then you only really interact with Kubernetes to spin up these applications.